Question 8. In the figure below, OP is equal to P and OR is equal to R. Vector OS is equal to 2R and OQ is equal to 3 over 2 P. Part A, express in terms of P and R, 1 QR, 2 PS. Part B, the lines QR and PS intersect at K such that QK is equal to MQR and PK is equal to NPS, where M and N are scalars. Find two distinct expressions for OK in terms of P, R, M, and N. Hence, find the values of M and N. Part C, state the ratio PK is to KS. So we start by interpreting the information given. We have been told that OP is equal to P. So from O to P is equal to P. Then from O to R is equal to R. Then vector OS is equal to 2R. So from O to S is 2R. And then OQ is 3 over 2 P. So the whole of OQ is 3 over 2 P. Then we are required to express in terms of P and R, QR. So question A, Roman 1, we need to express QR. Now from the diagram, QR, Q to R can be gotten by moving from Q to O, then O to R. So QR is equal to QO plus OR. Now QO is a negative of OQ, so that is negative 3 over 2 P plus OR is R. And that is our expression for QR. Then PS, to move from P to S, we can follow the route P to O, then O to S. So PS is equal to PO plus OS. Now PO is a negative of OP, which is P, plus OS, which is 2R. So those are the expressions of QR and PS in terms of P and R. Now part B, we are told that lines QR and PS intersect at K such that QK is equal to MQR and PK is equal to NPS. We know the value of QR, which is M times QR is negative 3 over 2P plus R. And then if we open the brackets, we will have negative 3 over 2 PM plus R M. And then for PK, which is equal to NPS, we have N times the value of PS is negative P plus 2R. So if you open the brackets, we'll have negative NP plus 2NR. Now we are required to find two distinct expressions for OK in terms of PR, M, and N. Now OK is this distance. So we need to express OK, first of all, using QK and then using PK. So the first expression of OK will be equal to OK can be gotten by moving from O to P, then P to K. So we have OP plus PK. So this is equal to P plus the value of PK, which we have gotten here as negative NP plus 2NR. Factoring out the common vector, we have P into brackets 1 minus N plus 2NR. Then we can express OK using QK. So OK can be gotten by moving from O to Q, then Q to K. So this is equal to OQ plus QK. OQ is 3 over 2 P plus QK, which we got here as negative 3 over 2 PM plus RM. Now factoring out the common vector, we will have P into brackets 3 over 2 minus 3 over 2M plus RM. Now you realize we have two expressions for OK. We can call this one and this one 2. Now since both of them express OK, then it means we can equate them. So we will have P into 1 minus N plus 2NR being equal to the second expression, P into 3 over 2 minus 3 over 2M plus RM. Now equating the terms with the common vector, for instance, this is for vector P, this is for vector P, we will have P 1 minus N is equal to P 3 over 2 minus 3 over 2M. The vectors cancel, so we will have 1 minus N is equal to 3 over 2 minus 3 over 2M. You can call that star. Then you see the vectors that express that the terms that have vector R, we will have 2NR is equal to RM. So the R's cancel and we have 2N being equal to M. We can call that equation 2 stars. Now from equation 2 stars, we can see that the value of M is equal to 2N. So substituting that in equation star, we have 1 minus N is equal to 3 over 2 minus 3 over 2 times. Instead of M, we write 2N. So this is 1 minus N being equal to 3 over 2 minus 3N. Putting the like terms together, we have 3N minus N is equal to 3 over 2 minus 1. So 2N is equal to 1 over 2. So dividing both sides by 2, we will get that N is equal to 1 over 4. Now having gotten the value of N, we can get the value of M. M is equal to 2N. So this will be equal to 2 times 1 over 4, which is equals to 1 over 2. So the values of M and N are, M is 1 over 2 and then N is 1 over 4. Now part C. We are required to state the ratio PK is to KS. Now PK we have the ratio, we have this statement here, pk is equal to nps. So pk is equal to, the value of n is 1/4 ps. Now dividing both sides by ps over ps, we will have pk over ps is equal to 1/4. Now comparing in the diagram, according to this ratio, from p to k is 1, then from p to s is 4. That means that from k to s is 4 minus 1, which is 3. Therefore, the ratio pk is to ks will be equal to, from p to k is 1, and from k to s is 3.